In this video, I will discuss overlay analysis. Overlay analysis uses a variety of tools to overlay multiple feature datasets in order to combine, erase, modify, or update them, creating new output datasets. The erase tool is exactly what it sounds like. Like the clip tool, it functions like a cookie cutter, but instead of using the portion you cut out, you are using the leftovers. It creates a new output dataset by overlaying the input features with the polygons of the erase features. The areas where the two layers overlap are removed, leaving only the part where the input layer that was not a part of the erase feature layer is located. I used this while working on my thesis by erasing areas that were covered in bodies of water, as people cannot live as in have their homes directly on the surface of water. The identity tool makes a new shapefile that combines and creates new polygons where the input data was originally and where that data overlaps with the identity feature. If the identity feature is located where the input layer is not, it is removed. The areas that overlap are made into new polygons that contain data for both the input and the identity feature datasets. The areas that overlap will become new polygons and contain both sets of information, while the part of the input feature dataset that does not overlap will only have its original attributes. For example, say the input dataset contains different flower types and the identity feature contains hummingbird habitats. You could use this to find out where the hummingbird habitats are and where they are more likely to be located based on the type of flower in the area. Intersect is a similar tool to identity and the opposite of the erase tool. It overlays an input feature dataset and an intersect feature dataset, only keeping areas where both are located. Keep in mind that this only keeps data from the input dataset and does not add information from the intersect feature. For example, you could use this if you were trying to figure out which vegetation best attracts deer. If the input data shows the different vegetation types and the intersect feature dataset shows where the deer are, you can easily determine which has the higher population density. It does not matter if the intersect feature data is added to the table because all we need to know is that the deer are there. We don't care what kind they are or their age or anything else. We just care that they are located there. Symmetrical difference creates a new output feature dataset that contains areas where both areas do not overlap. Features or portions of features in the input dataset that don't overlap will be written to the output feature class. This could be useful if you are trying to determine the differences in the spatial spread of two different tree species that look incredibly similar and are located in the same environment, but you want to make sure that they are in fact different species for your analysis. Lucky for you, you just so happen to have these handy dandy shapefiles of the two different tree species. Now you know where to sample to have both different tree types with the least amount of chance of mixing up the two. Union combines the input and output feature datasets. All features and attributes from both datasets will be included in the output dataset. Similar to identity and very much like a Venn diagram, the features still exist on their own, but they have some similar properties and you need all of the information to be included in your analysis. This image looks the most like a Venn diagram, but in this case, the data itself does not matter. The Count Overlapping Features tool creates a new feature dataset with a column that includes the number of times each feature overlaps with one another. Going back to the deer example, say you wanted to take samples from some deer and you have a dataset that includes the type of vegetation they like best, another with their known roaming ranges, and another that has drinkable sources of water. You would likely want to begin taking samples in area with the highest count because they are the most ideal and therefore most likely to have a deer population, in theory. If you were to do this analysis in reality, You would have multiple areas with different levels of suitability, making it easier for you to pick and choose multiple sample locations.